Welcome to Stephen Codecraft. In this free video series, we'll cover the essential JavaScript concepts needed for technical interviews. On stephencodecraft.com, click on the free courses nav link to access all course materials. You can download a free PDF with the transcripts, exercises, and view the GitHub links for starter and finished files. Also check out our free trial to explore premium courses on JavaScript, React for web development, and React Native for mobile apps. In each lesson, we'll break down key JavaScript concepts with real-world examples. We'll use the active recall study questions to help you prep for phone screen interviews, and apply your knowledge through guided coding exercises. Let's get started. Welcome to this lesson on JavaScript basics. In this lesson, we'll cover the fundamental concepts and terminology of JavaScript. Understanding these basics is key to writing effective code and working with the language's unique features. So what is JavaScript? JavaScript is the primary programming language for the web. It's a general-purpose, multi-paradigm language with dynamic typing, primarily used to add functionality to websites. So let's break down this description. So its key characteristics, first being multi-paradigm. JavaScript supports multiple programming styles, giving developers flexibility in how they structure their code. Dynamic typing. Variables can hold values of any type, and their types can change during execution. Interpreted language. JavaScript runs directly in the browser through a JavaScript engine. Modern engines use just-in-time compilation for better performance. So let's cover more examples of programming paradigms. JavaScript support for multiple paradigms makes it a versatile language. Here are the main paradigms. Event-driven programming. In event-driven programming, functions respond to user interactions such as clicks or scroll events. So let's see an example of this. So in our project files, we will expand the folder JavaScript Basics. And here we have a folder named _lesson. Let's add a new file, and I will name it index.html. So I'll do Command V to provide us more room. I'll do an exclamation point, and then tab. So VS Code will generate this boilerplate code for me. So we have a basic skeleton of an HTML page. Let's just add a simple button element and the text, click me. Now I'll add a script element, and within it, I will get this button, so I can say document.querySelector of the button. So for this example, I'm just showing how event-driven programming can be implemented. If you're unfamiliar with the syntax, we will cover this in a future lesson. So now let's add an event handler. So I can say add event listener. So on the click event, we want to run this code. So the event handler will simply log to the console that the button was clicked. And that with a semicolon. So let's open this up with Live Server. So we can do Command Shift and P or Control Shift and P if you're on Windows to bring up the command palette. And then Live Server, open with Live Server. So this will open up a web browser. So let me zoom in with Command plus. Now you can right click and select Inspect. We'll click on the Console tab. Now when we click on this button, we see it executes button clicked. So this is an example of event-driven programming. Navigating back, we can stop Live Server. So bring up the command palette and stop Live Server. And then Command B to show the sidebar. So another programming paradigm is functional programming. So this focuses on writing pure functions. So functions that return the same output for given inputs without side effects. So functional programming consists of first-class functions. This refers to functions being treated as values. For example, you can assign a function to a variable in JavaScript. In functional programming, there's also a term known as higher-order functions. So this means that functions can take other functions as arguments or return functions. So let's show an example of that. Here in the same directory _lesson, I will add a new file, and I'll just call this program.js. Close the sidebar so we have more room. So to show an example of functional programming, I will add a new file to our directory _lesson, and I'll name this program.js. Command B to close the sidebar. So let's implement a function that demonstrates functional programming. So I'll use the modern ES6 function syntax. It takes two parameters, and then our arrow function will simply add these values. So let's output this, so I'll console log it, calling add, adding 2 and 2. Let's start up Quokka, and we can see the result. So Command Shift and P, and start on the current file. And here we see our expected output of 4. So this simple function is an example of a pure function. Because in this case, if we pass it the same input, it will always provide the same output without side effects. So let's show an example of higher order functions. So higher order functions, once again, refers to functions being able to take other functions as arguments or to return functions. So I can call this apply function. I'm going to hide this with Command and J, just so we can have more room. And for its parameters, the first parameter, I can call it func for the function that it accepts. And then the parameters of x and y. And for the body of this, it simply calls or invokes that function. So now let's utilize this. I can say console.log of apply function, taking in this function that we defined earlier. So we're passing it as a parameter. And then we'll say the values of 2 and 3. So here we see in Quokka, it gets the expected result of 5. Let's highlight this and we'll comment it out with Command and /. Another program paradigm that's very often used is object-oriented programming. So objects can store data and methods and inherit from other methods. To show a quick example of that, we can say const car, and we'll use curly braces for an object literal, and we'll end it with a semicolon. We'll say the brand, in this case, we'll say Audi, and we'll define a method. So I can say console.log start car. We can end that with a semicolon. And then we can simply invoke that method. So here we see it has executed the expected console log statement. So this is an example of object-oriented programming using an object literal. So basically it allows us to group together related data and behavior. And this is useful as our applications grow because our code becomes more complex. So we want a way to organize it. Once again, we will highlight this and comment it out. So let's discuss imperative programming. So this programming paradigm explicitly defines the control flow using loops, conditionals, and statements. So a simple example of this can be a traditional for loop. So I can say for let I is assigned to 0, while I is less than 5, then we can increment I, and then we'll simply console log the value of I. So here we see in Quokka, we get the expected result, so from 0 to 4. Comment this out. And the fifth program paradigm we'll discuss is declarative programming. So this focuses on describing the desired outcome rather than the control flow. And this is often used in functional programming. So to show an example of this, I'll create an array literal with the values of 1, 2, and 3. And I'll use the declarative method of for each. So we'll pass in an arrow function as the parameter. And I'll console.log the value of num, ending that with a semicolon. And if we bring up Command and J, we can see that we get our expected result, 1, 2, and 3. So these are 5 programming paradigms that you can use in JavaScript. Let's comment this out. And we will stop Quokka with Command, Shift, and P, bringing up the command palette, and then stop current file. Close that. So now let's discuss the different data types and primitives in JavaScript. So JavaScript has 7 primitive data types. These include the number data type. So this consists of numeric values, including integers and decimals. big int for integers too large to store as numbers, boolean, which are the values of true or false, string, which are sequences of characters, the symbol data type, so these refer to unique identifiers created with the symbol function, null, which is an explicit assignment of no value, and undefined. This is a value that has not been assigned. The eighth data type of JavaScript refers to objects. You can check the type of a value using the typeof operator. However, note that typeof can also have some unintuitive behavior at times, such as returning function for functions even though functions are objects in JavaScript. So this is done for backwards compatibility with older versions of JavaScript. JavaScript's evolution. JavaScript is constantly evolving, with updates standardized under ECMAScript. One major update was ES6 in 2015. So this was a major update introducing modern features like the let keyword, const keyword, arrow functions, and template literals. Annual updates. New features are added yearly, ensuring the language remains up to date. However, it's important to note that it may take time for all browsers to fully support the latest features. So developers often need to use tools like polyfills or transpilers such as Babel to ensure compatibility across different environments. Some key JavaScript features. Automatic semicolon insertion. JavaScript adds semicolons to the end of statements where it thinks they're missing, but it's best practice to include them explicitly. Math functions. This is commonly used functions such as math.floor, math.random, and math.pow. These functions are often used in programming interviews. String and number conversion. JavaScript provides methods like number, parseInt, and parseFloat for converting strings to numbers. Let's dive into more examples of these math functions in JavaScript. So let's first consider math.floor. I'll add a comment here. So we're continuing with our program.js file. So I'll say example of math.floor. So this rounds a number down to the nearest integer. So I can say console.log. I'll do math.floor, and I'll say 4.7. So this rounds down. Let me correct that spacing. So our expected output would be 4. So let's bring up and start Quokka. So bring up our command palette, Command-Shift-P, and start on the current file. So here we see our expected output of the value 4 as it rounds this decimal value down. Let's show another example of that. So just to copy this, I'll do Shift, Option, and down arrow to copy this line. And let's make this a negative value. So here we see this rounded down to the value of -5. So now let's go over an example of math.random. Let's update this as well. So this generates a pseudo-random number between 0 inclusive and 1 exclusive. So I can do console.log of math.random. So in this case, it generated this random decimal value. Now, if we wanted to generate a random integer between 0 and 9, let's comment this out. We can do console.log of math.floor. So we're rounding down, and then we can generate that random number. So I can say math.random and multiply that by 10. So here we see it generated the random value of 5 in this case. So let's comment this out for now. Now let's cover an example of math.pow. So this returns the base raised to the exponent power. So in this case, we can do console.log math.power of 2 raised to the power of 3. So here we get the value of 8. Let me add the semicolon in the right place. So this would be equivalent to using a different operator. So we can achieve the same thing by doing 2 and then 2 asterisks, raising to the power of 3. So now let's cover the string and number conversions in JavaScript that I previously mentioned. So I can say example of number. So this converts a value to a number. If the string cannot be converted, then it returns not a number. So I can say console.log. So we're calling the function number, and we'll pass in a string containing the value of 1, 2, and 3. So here we see this cast it, or converted it, into its numeric equivalent. So let's show more examples of this. I'll copy this by doing Shift, Option, and down arrow. And let's add ABC. So here in this case, when we tried to call this number function and tried to convert it into a numeric value, we got not a number, because it contains the characters A, B, and C. So we can do Shift, Option, and down arrow. In this case, let's pass the Boolean value of true. So here we see, when we converted it, it converted to the value of 1. So in JavaScript, the value true converts to 1, and false will convert to 0. So we'll turn it back to true for now. So let's cover an example of parse int. Let's add that comment here. I'll just copy this to save us some time. Parse int. So this parses a string and returns an integer, stopping at the first non-numeric character. So, for example, we can do console.log of parse int, and then we'll pass in a string value 1, 2, 3. So it converts it going from left to right. So once again, we can do ABC. So once again, it converted it into the numeric value 1, 2, and 3, and it stopped parsing it once it came across the letter A, since A is not numeric. Now we can do, let's do ABC, 1, 2, 3. In this case, it returned not a number, because the first character it encountered was the character A. Now let's consider parse float. This refers to a floating point, or in other words, a decimal. So this parses a string and returns a floating point number. So I can do console.log parse float of 1, 2, 3, 4, 5. So it's converted it successfully. Let's do Shift, Option, down arrow, and I'll copy this line. Let's add ABC. So once again, it converted it from left to right, so we get the same value. And now let's do ABC, and this converted it to not a number. So these are essential functions when working with numbers and strings in JavaScript. So let's cover working with objects, with JSON stringify to convert objects to strings, and JSON.parse to convert strings back into objects. So I'll say example of working with objects. So let's create an object. I'll name it person, and it's object literal with my name, Stephen, and my favorite language, which is JavaScript. We can end that with a semicolon. Now, we can convert this into a string, and here, I simply pass in the name of the object. Then we can do console.log, json.parse, and then the person string. So here we converted it back into a JavaScript object. So now let's consider the maps and sets. So maps and sets are built into JavaScript, and they are very useful in programming interviews. So maps allow any type of key with built-in methods for key value management. So in JavaScript, objects refer to key value pairs, and the keys are always the string data type. But the map data type allows the key to be any data type. Next is set. So this ensures unique values and provides methods for adding, deleting, and checking values. So let's go into an example of the map data structure. So let's instantiate a new map. I'll say map equal to new map. And then we can add key value pairs. Add key value pairs. So I can do map.set with a name with the value of Stephen as my name. Now we can also, I'll say 7, and I'll say favorite number. So in this case, the key refers to a number data type. We could also use, for example, a Boolean value as a key. In this case, I'll just say yes as the value. Now we can access those values with the get method. So I'll say access values. Scroll up, I can say console.log of map.get. So we're using the name as the key and we're getting its associated value. So let's do Shift Option and down arrow to copy this statement. So I can say the value of 7, using the key of 7 gets the value of favorite number. In this case, the Boolean value of true returns its associated value of yes. We can also check if a key exists before trying to access it. So I can say check if a key exists. So I can say console.log map.has, and I'm checking if it has the key of name, and it returns a Boolean value of true. We could also delete a key value pair. So in this case, we can call map.delete, and we're deleting the key value pair where the key is 7. So if we try to check if the map has that 7, we get the value of false because this key is not found in the map. Now we could also iterate through the map. So in this case, we can just use our for of loop. So we'll get, what we're structuring here, our key and our value of the map. And we can simply console log that. So we'll use template string, so backticks, and then a key, and then our value. So this outputs all the key value pairs of our map. We could also output the size. So I'll say get the size of the map. Say console.log map.size. So in this case, there are 2 key value pairs stored in our map. Save that. So now let's go over the set data type. So I'll add a comment here. Say example of set. So let's instantiate new set. And let's make this larger. So Command and plus so you can see it better. And I'll close the sidebar with Command B, which would be Control B on Windows. So now let's add to this set. Once again, a set data type contains unique values. So I can say set.add the value 1, and I'll do Shift Option and down arrow just to copy this line. I'll add the value of 2, and I'll duplicate this line as well. So let me add a comment here. I can say duplicate will be ignored. So let's start with Quokka. So Command Shift and P to bring up the command palette, and then Quokka, start on current file. So let's continue. I have set.add the value. I'll add the string of hello, and then I'll do set.add and the value of true. So now we can check if a value exists in the set. So let's console.log set, and the method is .has, which will return a Boolean result. So the set contains the value of 1. So I'll do Shift Option and down arrow to copy this line. And I'll check if it has the value of 3 in the set. So here we see the output is false. Now we can also delete a value. So I'll say set.delete the value of 2. And let's console log set.has the value 2. And we get the value false as it was deleted. Now we can also iterate through the set with a for of loop. So I can say for const value of set, and we just console log that value. So here we see the value of 1, the string of hello, and the Boolean value of true. So let's discuss some of the key differences of the map data type and the set data type. So for the map data type, its purpose is to store key value pairs, and the keys can store any type of key. So this could be a string, a number, or boolean, or any data type. So the methods of the map data structure contains the method set, get, has, and delete. And for iterating, it iterates over key value pairs. Now for the set data structure, its purpose is to store unique values. And the set data structure doesn't have any keys, it only contains values. And its methods are add, has, and delete. And for iteration, it iterates over the values. So these examples demonstrate how to use map for key value management and set for ensuring unique values. So in JavaScript, functions are first-class citizens. So this means that functions in JavaScript are treated as objects. They can be assigned to variables, they can be passed as arguments to other functions, and they can return other functions. So now let's discuss error handling in JavaScript. So JavaScript uses try-catch blocks for handling errors. So we can cover an example of that. I can use the try keyword, and then open and closing curly braces. And I can say throw new error. So this is how you would throw an exception in JavaScript. So I'll pass in the string, an error occurred. And then we have our catch keyword. So I'll specify the error as a parameter, and I will console log, or console.error, error.message. So now we do Command J. Here we see an error occurred when we console log this message. So now let's cover console methods. So the console object provides several methods for debugging. We have console log for general output, console.table, which displays tabular data. We have console.count, which counts the number of calls, and console.time, and console.timeN, which measures the execution time. So let's go over some examples of these methods. So first cover console.log. So this is the most commonly used method for debugging. So I'll add a comment here and I'll say console.log general output. So I'll say log and then tab as a keyboard shortcut. And I'll say hello world. And here we see it's outputted with Quokka. So if I were to do console.log, say the value of x is, and I can do comma and the value 42. And here we see outputted to the right. So the value of x is 42. Now let's create an object. So I'll say let new user. This will be object literal with the name of Stephen and the favorite language of JavaScript. And I'll console log, say new user, and then the new user object. So here we see it outputs that object. So now let's go over console.table. So this is useful for viewing arrays or objects in a tabular format. So I'll create an array, I'll say students. So the first student will have the name of John and the grade of A. And I'll copy this with Shift Option and down arrow. Let's rename this to be Jane. We'll say A minus, and we'll say Sam. We'll say B. So now we can do console.table students. So if I do Command and J, if I were to expand this, here I see this tabular output. So the index of the array, the name, and the grade. So let's close this with Command J. So let's cover console.count. So this counts the number of calls, and this is great for tracking how often a function or piece of code runs. So I can say function greet, which takes the parameter of the name, and I can say console.count greet function called, and I'll say console.log backtick. I'll say hello, and the interpolation the name. So now let's invoke our greet function. I'll pass in my name Stephen, And I'll do Shift, Option, and down arrow to make copies of this invocation. So now when I save this, here in our output, I scroll down. Let me comment this out, so I'm not getting that. I'm going to stop Quokka for now. So say stop current. And let's start it again. So now on the bottom here we see the greet function was called 3 times, as we invoked it 3 times. So now, I add this comment, so console.time and console.timeEnd. So this measures execution time. So this is useful for benchmarking code performance. So I can say console.time, and I'll say loop timer. So I'll say let sum is assigned to 0, and for let I is assigned to 0, while I is less than 1 million. So I increments. So sum plus equals 1. Then I can say console.timeEnd loop timer. I can save. Now if we open up, we scroll to the bottom. Here we see the loop timer. This is measured in milliseconds. So now let's discuss strict mode. So adding use strict at the top of a file enables stricter parsing and error handling, helping catch potential issues early. So this concludes the overview of JavaScript basics, and in future lessons we'll dive deeper into specific JavaScript features and their applications. What is JavaScript? JavaScript is the primary programming language of the web, mainly used to add dynamic functionality to websites. It is a general-purpose, multi-paradigm programming language with dynamic typing. What is a programming paradigm? A programming paradigm refers to a style or approach to programming, defining how solutions to problems are structured and implemented. Can you identify and explain the 5 primary programming paradigms supported in JavaScript? So the 5 primary programming paradigms include event-driven. This is where JavaScript allows functions to respond to events, such as a user clicking on an element or scrolling down a page. Functional programming. This is where functions in JavaScript can be written as pure functions, which always returns the same output for a given set of inputs without causing side effects. JavaScript supports first-class functions, meaning it treats functions as values, and higher-order functions, meaning functions that can accept or return other functions. Object-oriented programming. This is where JavaScript enables the creation of objects as custom data stores with the ability for objects to inherit properties and methods from other objects. Imperative programming. This is where programs are written by explicitly defining the control flow using constructs like loops, conditionals, and statements. Declarative programming. This is where programs focus on describing the desired outcome without detailing the control flow. This approach is often linked to functional programming, such as using the .forEach method instead of a traditional for loop for arrays. What are the 7 primitive data types in JavaScript? Primitive types are the most basic data types in JavaScript. They include the number data type, which includes numeric values, including integers and decimals, big int, for integers too large to be stored as the number data type, the Boolean data type, which is a binary value of true or false, the string data type, which is a sequence of characters, the symbol data type, which is a unique and dynamically generated value, the null data type, which represents a non-existent or empty value, and the undefined data type, which represents a value that has not yet been set. What is the purpose of just-in-time compilation in modern JavaScript engines, and how does it differ from traditional interpretation? Just-in-time compilation improves performance by converting JavaScript code into machine code while the program is running. Unlike traditional interpretation, which reads and executes code line by line, just-in-time compilation optimizes and compiles the code on the fly. This results in faster execution and better performance, as the browser applies optimizations during runtime. How does the map object in JavaScript differ from a standard object, and what advantages does it offer when managing key-value pairs? The map object differs from a standard object in the following ways. It allows keys of any type, including objects and functions, not just strings or symbols. It preserves the insertion order of key-value pairs. Advantages of using a map include built-in methods like set, get, and has, which make managing keys and values more efficient. This flexibility is particularly useful when working with non-string keys or when maintaining the key order is important. So we'll go over 2 coding problems, which will test your understanding of what we covered in the JavaScript Basics section. So we can expand the JavaScript Basics folder, and we'll start with exercise 1. So open up the PDF. So problem 1, which tests JavaScript data types and functions. So this tests your understanding of the type of operator, working with arrays, and working with objects with dynamic key-value pairs. So we'll write a JavaScript function called processData that accepts an array of mixed data types, which include numbers, strings, and booleans. And so this function should count how many items belong to each data type, and it returns an object where the keys are the data type, and the values are the count. So for an example, if it accepts the input with a number of 42, the string of hello, the boolean value true, 99, world, and false, the output will be an object containing key-value pairs. The number data type is the key, and has the value of 2 because there are 2 numbers in our array. Same thing with the string data type. There is hello and world, and for the boolean data type, there's true and there's false. So let's view our project files again. We can close this out. So within our exercise 1 folder, we have a directory for the solution and the starter files. So let's expand the starter files. We can select on program.js, and I'll close the sidebar with Command and B. So here we have our function, processData. We have our input, and then we are invoking our function. So pause the video and try to implement this on your own. Okay, so let's go over a sample implementation. Now there are different ways you can implement this. So this just shows one possible way. So first I will create a constant for the data type count. So this would be the object which will contain the key value pairs that we need. And I can just return this right away. So now we want to iterate through our array. So I can do this with a for of loop. So I'll say for const element of the array. So we want to get the data type. So I'll say the type using the type of operator, and then the element. So now I want to check if this data type is already stored as a key in our object. So I can do that with data type count dot has own property. Now there are different ways you can do this. For example, you could do the type in data type count. Right, so specifying this in the parentheses of our if statement. But I prefer to use has own property. So now I could do data type count using square brackets to increment the count. Otherwise, I will set the data type count equal, or assigned rather, to the value of 1 for its first occurrence. So now, let's actually start this up with Quokka. Actually, I will console log this so we can see our expected output. So Command Shift and P for our command palette. And we'll start this. So now we get our expected output. So the key value pairs of the data types for our input array and the expected occurrence count. So let's go over exercise 2. So we can expand exercise 2 directory and we'll view the PDF. So problem 2 covers event-driven and functional programming. So this tests our understanding of object-oriented programming, event-driven programming, and console debugging. So we'll create a simple counter application using JavaScript. So your task is to write an object called counter that has the following properties and methods. So the property count will be initialized to 0. It will have a method increment that increases the count by 1. It will have a method decrement that decreases the count by 1, and a method reset that sets the count back to 0. And then we will simulate user interaction by using setTimeout to call the methods in this sequence. We will increment the counter twice, we will decrement it once, and then we will reset the counter. So this shows an example of the expected output in the console. So after incrementing, after the decrement, and after resetting. So let's view our starter files. I'll close the sidebar with Command B. So here we see we have initialized our object, and we have our setTimeout functions. So we've already specified the time to wait before invoking this. So you just have to implement the utilization of the method. So pause the video and try to implement this on your own. So let's get started. So we want to set a property of count to 0. It has a method called increment. So this simply is a function. So we'll use the this keyword. So the property count is incremented. There's a method decrement. So this will simply decrement the count. And then we have reset. So this will simply set the count and assign it back to 0. I need to open and closing parentheses here. So now we will utilize these methods within the setTimeout function. So I can do counter.increment. And here in the console log statement, we'll use interpolation. And we'll say counter.count. So once again, counter.increment. And I'll just copy this to save us some time. We can do counter.decrement. Paste that in again. And then counter.reset. And then the interpolation paste it again. So we can start Quokka here. So Command Shift and P. And then we start on the current file. So there we see the setTimeout, the counter after the increment, so 1 and 2, because we called it twice, the counter after the decrement, and then the counter after we called the reset method.